Myself Pushpalata, Assistant Professor, Department of Electronics and Communication Engineering, Institute of Technology. Today we are going to discuss about the concepts of communication network, transport layer. Let us discuss about the transport layer concepts. Transport layer is located between the application layer and network layer of the TCP/IP protocol suite. The transport layer basically it provides a process-to-process communication between the different application layers. That is one at the source address and other one at the destination, which we can term it as the local host and the remote host. Or if we talk in terms of client and server paradigm, the local host is considered to be the client and the remote host is considered to be the server. Okay, so the communication is basically provided using the logical connection, which means that the two application layers can be, though that they are located at different parts of the globe, they assume that there is an imaginary direct connection through which the data packets are sent and received. Consider this is the example where the figure it shows the logical connection between the source and the destination at the transport layer. Now in this particular figure, let us consider that the source host, consider it to be the Alice, and he is in the Sky Research Laboratory or a company and creates a logical connection with the Bob, that is the destination, and Bob is a host in the scientific books company. Okay, now when the logical connection is established, okay, the two companies they start communicating at the transport layer as though that there is a real connection between the transport layer of the source and the transport layer of the destination. Okay, so the other layers would the transport layer would never come into picture in between the routers which we are using in the network. The transport layer services are many. So to name few of the transport layer services, let us discuss in the next slide. As we know that the transport layer is located between the network layer and the application layer, and it provides the services for the application layer as well. It tries to get the services from the network layer, and as we know that the transport layer has its own responsibilities, so among them few are discussed here. One of the services of the transport layer is process to process communication. When we talk about the transport layer protocol, okay, it's basically it provides a process to process communication. Consider that I have a client and I have a server, and the client has opened up many processes, okay, and in the simultaneous way consider that the server is also having is running with many processes. Now when we talk about the communication between the processes, okay, so that is the domain of your transport layer protocol. If you talk in terms of host to host, then that is the domain of your network layer protocol, right? So network layer is bothered about whether the destination host is reached, but the transport layer is bothered about whether within that particular device have I reached the right process, right destination process. Okay, so that is nothing but the process to process communication. let us talk about the addressing. Basically, when we talk about addressing, we try to give a unique identification number for each of the processes which are running at the local host as well as the remote host, and they are defined using the IP addresses. Now if I want to define the process, we need to have secondary identifiers which we term it as the port numbers. So these are the port numbers which are the unique identification numbers given for the individual processes at both the client as well as the server end. To discuss about the port numbers, in the TCP/IP protocol suite, the port numbers ranges from 0 to 65,535. That means the port number is of 16-bit. So 2 power 16 would comes around 65,535. Now with this concept, if we try to analyze that the port numbers are lying within this particular range, okay, so the client program will define itself with a port number, and that you can call it as an ephemeral port number. Okay, so the basically word ephemeral, it's like a temporary, or you can call it as short-lived. Okay, and it is used because that the client will run the process normally of a short duration, right? So the ephemeral port numbers are assigned for the individual processes at the host. Now there is there are different types of categories that the total port numbers are being categorized, which we will be discussing soon. Now with respect to the picture or the figure, whatever is shown here, this shows the concept where we try to make use of a well-known port number. Say for example, the daytime client is using some particular process whose port number is 52,000, and the server is using the same process with a different port number, that you call it as 13. So what happens is, whenever the information has to be shared, before this the TCP/IP has decided to use this information, that what are the port numbers to finally destinate the data. That is, like, the port numbers, they play a different roles in basically selecting the final destination of the data. The destination IP address, here it defines the host, right? And one of the processes which we are talking, and that process is being represented using the port numbers. When we talk about the IP address and the port number, we can have a better differentiation here, right? As I told you, whenever we are talking about the network or the host where you have to reach, where the information has to be reached, okay, so that will be identified basically using the IP address, and this selects the respective server, that is the host or the destination device, and this IP address is mentioned once the specific destination server is reached. Okay, then the processes will define the respective port number to reach the specific application. Okay, so who is going to maintain these port numbers, unique identification port numbers? We have something called as ICANN. Okay, so this ICANN, it's nothing but the Internet Corporate Assigned for Names and Numbers. Okay, so they have divided the port numbers into three ranges. Okay, so the three ranges can be considered to be the first one is well-known port numbers, or you can also consider it to be something like a permanent port numbers. Next we have registered port numbers, and third category is dynamic port numbers. So when we talk about the well-known port, this port is ranging from 0 to 1023, and they are assigned for well-known processes, like we try to make use of HTTP, Gmail, like that. Some of the processes which are like well-known processes which is been assigned by ICANN. Now the second category is registered category, where the ports ranging from 1024 to 49151, and they are not assigned. Okay, and but they are controlled by ICANN. Okay, so they are not assigned to any specific processes. Now when we talk about the next category, that is the dynamic ports, the remaining port numbers that is left with 491522, the last, that is 65,535, right? So these all port numbers, they are like neither it is being controlled, okay, nor it is being assigned. Okay, so neither it is controlled or assigned. So they are something called as like temporary or private port numbers. Okay, so these are some of the port numbers and its categories, and the difference between IP address and port numbers are discussed in this particular figure. So as I was telling, ICANN, it is the Internet Corporation for Assigned Names and Numbers, and they have divided it into well-known, registered and dynamic ports, and the ranges are specified here. So these are the ranges specified by the ICANN. Now let us talk about the next topic, which we call it as socket address. Now transport layer protocol in the TCP/IP suite, it needs both the IP address as well as the port numbers. So in order to basically make a connection, it requires both the IP address and the port numbers. The combination of this IP address and the port number is termed to be the socket address. Okay, so whenever a client socket, he defines the client process, he he uniquely, just as the server socket, try to address the specific processes at the server end. Okay, so here the client socket address defines the client process, just like the server socket address defines the server process. Okay, so talk about the socket address. You can have a better representation. In order to represent the socket address, I should have a IP address as well as the port number. The combination of these two would give me the socket address. And if it is at the client side, you call it as a client socket address. If it is server side, you call it as a server socket address. And these specifies the specific processes at the both the ends. The next concept is encapsulation and decapsulation. See, basically to send a message from one process to another, the transport layer protocol encapsulates and decapsulates the message. Now in the picture we could see both the concepts of encapsulation and decapsulation. Encapsulation always happens at the sender site, or you can call it as the client. Right? So when a process, for example at the application layer, now whenever it is having a message to send, it passes the message to the transport layer. Now when the transport layer receives the message, it along with the message it adds a pair of the socket address, and that is included in the header. The transport layer, it receives the data, adds the header, right? The packets which is framed at the transport layer, and they are now considered to be the user datagrams, or we also can call it as packets. Sometimes we also term it as segments. Now these packets, depending on what transport layer protocol we use, okay, they are being transferred or sent to the destination through the channel, and at the receiver end decapsulations are, it happens at the destination. So when the message arrives at the destination transport layer, the transport layer tries to drop the header part, whatever is being received, and send only the message or the information to the upper layer, that is application layer. The sender socket address is passed to the process. The socket address comprises of the IP address as well as the port number. Now what happens is, in this case, the sender, as we know that the sender socket address is passed to the process in this case, and it needs to respond to the message which is being now received, right? So that means you call it as an acknowledgement once you receive the message at the application layer. The next concept we are going to talk about is multiplexing and demultiplexing. Whenever an entity or the host accepts the items from more than one source, okay, so let me take up an example of two different layers here, that is a application layer and a transport layer. Okay, there are many processes defined at the application layer, and all are ready to send the information, wherein which the transport layer would receive all these packets. And how it is going to receive, it is like multiplexed. So all the processes, like many processes are given to the multiplexer, and each one is received one after the other. Okay, so it is many to one concept, that is the multiplexing. And the figure especially shows that we have a client and two servers here. Okay, you can see this is server 1 and we have server 2, and these three client processes are running at the client side, that is we call that P1, P2, P3, and they are sending the messages called M1, M2, M3. At the transport layer, what happens, it is getting multiplexed, and the transport layer at the client side accepts the three message and creates three packets. Okay, so basically it is acting like a mux, that is multiplexer. Now what happens, the packet 1 and 3, right? So here they use the same logical channel to reach the transport layer of the first server, and packet 2, it uses the different channel to reach the server 2. Now what happens is, the packets 1 and 3, that means when they arrive at the server, the transport layer here, it does the job of demultiplexer. That is, it tries to distribute the messages to two different processes, which are connected or which are running at the application layer. So when I talk about the demultiplexing process, okay, here you can see that the packets 1 and 3 are being distributed to the processes 1 and 3 of the application layer, and similarly packet 2 will be received and it is demultiplexed and it is sent to the application layer of the server 2. The addressing mechanism allows multiplexing and demultiplexing with the transport layer. Whenever an entity accepts data from more than one source, this is referred to as multiplexing, that you can consider as many to one. Whenever an entity delivers items to more than one source, this can be considered as demultiplexing, where the information flows from one to many people. The transport layer is present at the both source end as well as the destination end. At the transport layer at the source performs multiplexing, and at the destination end it performs demultiplexing. So at the sender side there may be several processes which needs to send the packets. However, there is only one transport layer protocol at any time, and this is like many to one relationship and requires multiplexing. The protocol accepts messages from different processes which is differentiated by their assigned port numbers. After adding the header, the transport layer passes the packet to the network layer. Now when we consider the demultiplexing part, at the receiver side the relationship is one to many and requires demultiplexing. The transport layer receives datagrams from the network layer. After error checking and uh, the correction of the header, or if you want like dropping of the header, the transport layer delivers each message to the appropriate process based on the port number. So this is all about the concept of multiplexing and demultiplexing at the transport layer. So we'll continue the further topics in the coming sessions. Thank you.